Okay, we are back with the second demo jaw. As you can see, this second demo changed the design of the jaw considerably in order to hold a different kind of part. Basically, I want to try and see how much torque I could apply to a clamped workpiece. This is all in preparation for an eventual drilling test that we're going to be trying to set up to do. So this is the reason that put such a big radius in here. I'm actually going to be holding on to 30 millimeter impact socket. That's going to be our test part for this demo here. So some of the design parameters for the jaw. This radius here, 855 thousandths. I offset the two jaws by 100 thousandths in my CAD software. So we've got a really good wrap on the actual socket itself. The depth of this is 1.5 inches, and I increased the counter bore diameter here to 1.41 inches so that I can actually accommodate a large fender washer, and then I'm putting another washer on top of that just to increase my my bearing surface, and that really improved the amount of clamping torque that I could apply to those 1/2-13 fasteners. And I did go ahead and lengthen the fasteners as well to make sure I didn't damage anything. So and then the counterbore depth here, that is now 590 thousandths. So that gives us considerably more meat from the back of the counterbore to the back of the jaw, which helps substantially. So I'm going to go ahead right now and install the fasteners here. I am going to leave them somewhat loose so that I can line up my socket in the jaws, where the jaws will still slide laterally somewhat. Just run these down sort of just a little bit more than finger tight. And again, this jaw is reinforced with fiberglass, and I'm going to show you a close-up of that a little bit later. I learned something from the first demo there. Again, don't want to get these too tight. It needs to be able to move laterally just a little bit for alignment purposes. There we go. So now got our target to clamp. Run this up here. Slide over there where it needs to be. Back this off, and now I'll torque my fasteners. And another thing that I found out here too, when I was doing my my initial testing with this, you'll see some sandpaper laying here. Had to do the old machinist trick there. I want to thank Mr. Mike Marshall for his input on this project. Again, I'm going to be torquing this to 50 foot-pounds. Now you remember from the first demo jaw, I was only able to put about 20 pounds of clamping force on there before it felt like something bad was going to start to happen. There's 50 foot-pounds. That's no problem. 50 foot-pounds on both of those. Those torqued up. Back to the old machinist trick here. When I did my initial testing here, these jaws are very hard. They're very hard, and they have a bit of lubricity to them, this hard plastic. And you know, this surface here is quite slick, this the finished surface on this socket. So I was not able to get, I was still able to get some pretty good numbers, but not nearly like I was able to get once I added my sandpaper. Where'd my other sandpaper go? Here we go. I'm going to add this in here, run this up, clamp this down, and then we're going to take our torque wrench. We're going to try and turn this socket. Let's see how much clamping, or how much force we really have, rather, applied to this, because that is going to tell us a lot about what we can actually do with these jaws as far as machining apart. Slide that down in there. Bring it up a little more. Get that where we want it. Bring this up here. And again, we're going to be applying the same 50 foot-pounds of input torque just double check, 50 pounds. And now, let's see, there's 50 pounds, that's no problem. Let's just jump right on up here. Let's just jump right on up to there's 100 foot-pounds. So that's no problem. Let's try taking this up to 110. It's hard to hold. Let's try 120. So 120 foot-pounds, it actually broke loose. So 110 foot-pounds is quite a bit of torque. And again, that's with only 50 foot-pounds of input torque applied here. So I'm wondering, just to see, let's bump this up to 60 foot-pounds and see if that actually makes a difference. Set back up here. Go right back to 120. Let's see what happens. I don't know if I can hold this or not. So I'm going to stop at 120 because then you're starting to hurt. So now let's take everything apart and let's see. Now I'd never actually run that up to 60 foot-pounds before on the input torque, so I don't know what this might have done. It might have deformed our jaws. I just don't know. We're going to plow some new ground here together and see what we come up with. So far, everything's looking good. And again, here in a second, I'm going to do a close-up for everybody. So I'm going to go ahead and stop the footage right now, and we'll do that close-up.